From deep inside the Death Star, I'm Larry Larson.
And I'm Andrew Richards.
And welcome back to Defrag. So last week we were talking about Process Monitor.
Yep.
And went over some of the menus, some of the shortcuts, ways to filter out the noise and try to get to the types of things that you're trying to locate, troubleshoot. Where are we going to pick up today?
So Process Monitor is one of those tools that unless you see it in action, you're just not going to get it. And that's what we're going to do today. We're just going to do example after example after example and just delve right into it and find out how you do individual targeted analysis, how you do broad analysis and stuff like that.
Cool. Let's get started.
So full disclosure here, I am not the entire brains behind this. I have a whole lot of team back in my office that help me work out what we're going to do, right? It's very hard to work out a good example. I can give you tons of bad examples.
Yeah.
I'm very good at that. But particularly this episode today, Chad Beta helped me extremely to work out exactly what we want to show.
Yeah.
And so full disclosure, Chad, thank you very much for
Thank you, Chad.
for your help. So let's start Process Monitor up. And we're going to reset the filter, which you can press Control R for as well, and just let this thing go. Actually, this is from the last show, so sure, we'll just override that. All right, so we're going to be doing something that is about registry tweaks. And actually, on Defrag a couple of weeks ago now, I did a tweak, showed you how to turn Aero Snap on and off, which is the system that lets you dock to the top of the screen.
Yeah.
I have another one, and Chad, this is what Chad's favorite one that I personally do, and nearly everybody does, who's a power user, is you go Tools, Folder Options.
It's one of the first things I do.
Yeah.
Yeah.
And then you turn these two on. And so what that does is shows you all the folders, and then if you expand something, it follows you down.
Yeah.
So our tracing's been happening, so we're finished tracing, so that's stop capture. We are looking for a configuration change, and Windows puts configuration in the registry. And so we can exclude a whole lot of things. So let's get rid of the files, let's get rid of network, and let's get rid of profiling. And so here's all of the registry operations that happened during that time. Well, we were using the program Explorer to modify Explorer, so we want to find explorer.exe, and there it is. The other way of doing it, which is I tend to take this approach myself, is you go, it's not that, exclude, it's not that, exclude, it's not that, exclude. More when I'm looking for paths and stuff, that's not that, exclude. Oh, here it is.
Digital whittling.
Yeah, and include. So here's all the operations that, registry operations that happened from when we started tracing to when I finished tracing, which was after I set that key. I don't know where it is in here, all right? What I do know is it was probably successful. Right, it's kind of obvious. So in this case, we can say, just show us only the successful ones. So we're slowly whittling down. And then we've got still a fair few in here. And what we can do is go, well, let's just get a quick overview of the registry keys that this thing touched. And so you can go Tools and then Registry Summary. And what we can do is sort by path. And lots of CR, HKey classes root.
Yeah.
The data shown here is based on the filter out here. And so what we can go is go exclude, see a little CR there, exclude that, and then it took out the whole path, so that I can jump back to the filter, and then the exclude, where is it, is here, double click on it, let it go up the top, press delete, go, begins with classes root, OK, and then all the classes roots have been culled out. Close this, refresh it, Tools, Registry, and then, whoops, and then we now have it. Oh, it didn't filter down. Oh, anyway. So we have a whole lot of paths. Oh, sorry, it did. It's current user now. I've got CU and CR.
Yeah.
And so there's a lot of current user stuff, a lot of things to do with classes again, which is a bit of noise. Internet Explorer, that's not it. Current version Explorer, and then, oh look, here's a big area where it looks kind of useful. And without having to delve down through the entire list, I've kind of worked out where we were in the registry and stuff like that.
Yeah.
And here we are. Well, that's kind of interesting. Show hidden files, hide file extensions, which is kind of the same area. And Yeah, it's just lots and lots and lots. So we know it's kind of in this area, so we can filter to that. So let's press filter on that. And we're going to say the path contains, I can't be bothered typing it all, advanced, which is over here on the right.
Mm-hmm.
Close this, and there we're down to that. Well, we only want operations that change the key. We don't really want, hey, this I opened it, I closed it. And so let's get rid of all the open keys, because that's kind of pointless, and let's get rid of all the closes, exclude. And then query is reading. Well, we didn't read it, we want to write it, so that's not it. And there you have two set values. Create the key, make sure that the key exists. That's not what we want. And there we have two reg set values.
Very cool.
And this is one of my tips for the day. If you're looking for, I mean, I did it the hard way on purpose.
Yeah.
If you're looking for a registry key that got set, just filter on operation reg set value.
Yeah.
The other way you could have done it is, let's go back to filter and get rid of some of this exclude that I did. We can just disable these. Lots and lots of operations here, and here's those operations we're talking about. There's a menu called count occurrences. And you can say, for the operation column, show me how many there are. And so there you are. There's the 5 operations that we're currently filtered down to, and there's the set value at the bottom. And since I checked 2 checkboxes, I'm not surprised to find 2 set values. So once you've gone that far, you can then actually get rid of these guys. So we'll go include just reg set values, and then we can go jump to, and that jumps to the registry, and there is the area, and then off you go. Once you have this key.
What is super hidden over there? I'm intrigued.
Ooh, should we? I wonder if it's hidden files owned by the system. System hidden files.
Super hidden.
Rather than hidden. Well, hidden would be the hidden files, right?
Yeah.
So hidden probably. Should we? No, not.
No. Don't start messing around registry.
All right. So copy the key name, and so actually we'll copy this whole one here. Show all. Expand to current folder. So we'll copy this guy. Copy. And actually, I can do it from in here. Wrong one. We can go search online. That's not what I wanted this. And then there's a social page, and then here's an official TechNet page. Obviously, I've been here before, telling you what this is. And then the other one right next to it is a page explaining every single one of these. Actually, here's your super hidden. Super. Oh, it's not even listed.
Oh, it is super hidden.
It's super, or is it not? No, it's not even listed. That's kind of cool, isn't it? You're a troublemaker, you know that?
No, I do.
So this is a group policy page. So if you want to officially change this, what you would do is follow these instructions, and it would tell you how to set group policy up to set it. So across your corporation, you would turn it on. All right, so that's a kind of an interesting example. All right, so that was a very targeted, we want to go down to a very specific answer. So let's reset this guy. And so it's just tracing again. And actually, and I'll press Control X to clear it out. Let's do the other way of looking at it. Let's do a holistic example. And I'm just going to go to my favorite website, the Defrag Tools site.
Very nice.
So we're currently tracing, data is, actually, no, I'm not tracing. Let's do that example again. Let's close that and start again from scratch. Control X, because we're in a resets point. Go to defrag, and let's trace what this IE did. And I'm going to click on the first episode, and I am going to start downloading this guy. And we'll just shove it into dumps, which is where I put all my temporary files. And that's downloading. So we're tracing file activity as the file gets hit to disk. We're tracing network activity as it goes over the wire. We're tracing registry activity as Internet Explorer checks security policies and all that type of junk. You'll have profiling events happening as this is using CPU power up. And the last one is load events, which is you'll see threads starting, processes starting, all that type of stuff. So that's all happened. You can press stop the capture. And this is what all these menus are, and we skipped this over in the first episode because it's much more useful to see the tree of events.
Yeah.
Process tree. So process tree is a fantastic tool, and particularly this one over here. We launched a program ourselves, so I'm going to get rid of services.exe because it's not in our profile. And you can see here, here's Internet Explorer. See how it's grey at the moment? It's because I closed it. But you can see this is where it started, then it made a child process, and then it ended. All right? And so you can see over time how things happen. Back in the operating system, you can see here's some other stuff that started and stopped. Process tree lets you filter to the process or all the ones under it. So let me show, if I go include subtree, it will filter to this guy and this guy.
Yeah.
So a great way to see a tree of execution. The file summary, process activity summary. So this is kind of like looking at Process Explorer's graphs, but over time. So we're just looking at these two guys, and you can see here there's graphs for each thing. So there's the file activity of this guy. It's over the duration of how long process module was running, so we're in that last period. This is how many events there were, and this is how many bytes there was. So there was a lot of file I/O here, but the first one had a fair bit of registry I/O comparative to the second copy.
Yeah.
Lots of network, not surprising.
Yes.
And what you can do is use this graph, particularly if I just do a reset and show everything, you can use this graph as a good way to just look at the entire box and go, why is this being busy and what's happening? So the file summary, we kind of used this same concept in the last one. You can look at usage. All right, who's been hogging my hard drive? Well, there it is. There's the partial file for the download that was used up most of my hard drive I/O. Using the counts is kind of good. So look, there's 30,000 temporary item hits.
Yeah.
So it's kind of good to know, well, why is my disk thrashing? Why is it, lots of small I/Os are not good for performance. So good way of slicing and dicing that data. I did the registry one before. Thinking, lots of registry things. That's kind of self-evident. Stack summary. Stack summary has limited effect. You need to have symbols. This is going to take a while because it's going to have to look at the stack of every single event, which is obviously a fair bit of work.
Yeah.
What you can do is trace the CPU power down to the function. So with the Microsoft public symbols, you can do functions. With your private symbols, you can do it down to the line of code. And what you get is a big tree of all of the, I called into foo, and foo called into bar, and then it called into car, and then it called into cat. And you can see a split of 3 and the proportion of the CPU power. And so I'm not going to delve into this because it's quite lengthy analysis, but you can see that this guy used 74% of the CPU power. You can see it right there in the middle. And then it's going to have to crunch and crunch and crunch. This is one of those things that does take a while to go through. 91% went into that function, and we just go down and down the rabbit hole as you go. But if you're trying to work out in your own program why it's running so hot, very quick tool to work out where the CPU power went. And cross-reference summary. So if you're trying to find out, I opened a file in program A, and then B complained that it couldn't do it. So these are all the files. These are the people who have write access to the file, as in this file here, and these are the people who have read access to the file. So when you're having a sharing issue and going, well, what's the deal? You can do the same thing kind of in Process Explorer, but it's more timely, right? Process Explorer only shows you now, where this gives you all time. You can narrow your search down to a band and go, in this period, who had the lock an hour ago.
Yeah.
Very, very powerful. And then count occurrences, which I've went through. Very good for statistical analysis. The main one that gets used a lot is result. And you can say, show me all the things. And so access denied, there's 206 of them. That's kind of interesting. Let's sort by a big one. 394,000 successes. That's good. And then just go through here. Mark Krasinovich gave an example at Case of the Unexplained at TechEd 2012 where his laptop was frozen at login. And he actually used this technique, and he found an entry called bad network path. There it is. And that slowness trying to access this share was the reason why his Explorer jammed for 45 seconds or whatever it is. So
very nice.
Yep.
And today we're going to do another example. We're going to determine why a machine boots slowly using Process Monitor. And tell us a little bit about this. This is a question we get all the time on defrag.
Yeah, so the problem with boot analysis is, well, how do you run a tool during boot? You can't bring up Process Explorer and stuff like that while it's still booting. So what we need to do is get the system to start some tracing at boot and then do the analysis once we've logged in. And let's do this live. Let's jump into it. Run Process Monitor. Make sure you do a reset so we get everything. We're going to put it to that file. That's fine, that's kind of relevant for now. Enable boot logging. What this does is make a new file. It makes a file in C:\Windows. And what we want to do is turn on thread profiling because we're going to need to know what programs are actually thinking, what their logic is. Press OK. That's now set. We've changed the device driver to be a early boot device driver, and so now if we reboot, we're going to get a trace. And I'm going to do that straight away. My video is going to disappear, and you're going to have to put up with me and Larry on the screen for a little while as this thing goes down and does a reboot. So as soon as Windows starts, the log file will start, and the logging starts really, really early in the boot process. The log will go as long as until you tell it to stop, which means you can go from start up all the way through to shut down if you just never stop it. Once it's run once, it sets itself up so that next time you boot, it won't. So you can go through a whole cycle, come back up again, so like two reboots away, and then it will be still preserved. You're not going to continually reset yourself. So Windows is starting. I know you can't see it on the screen. It doesn't take too much performance hit, but it is there. It does slow it down a bit. I mean, you are making a whole lot of disk I/O.
Yeah.
So we're nearly up to Windows. It's kind of duality. I want it to boot fast for the show, but we need a slowness to analyze, don't we? So
of course.
So that program where you do Control-Alt-Del is a program called WinLogon. It makes a program called WinInit, which is a program that worries about logging you in. It's all done under the guise of a thing called SMSS, which is the Session Manager Subsystem. There's lots of acronyms in Windows, isn't there?
Tons.
So that's I'm going to cut this off pretty short. Run Process Monitor. Has to be done elevated. Do you want, and this is the dialog you'll get, do you want to save? And you say yes. And actually I'm going to make a new folder called example. And this is now, there's a file inside the Windows folder which is PMB, Process Monitor boot log, as opposed to PML. If you don't close, if you just try copying that file, it won't work.
Yeah.
You have to go through this process, otherwise you'll have a damaged file. Same thing goes with when you're just doing straight Process Monitor logging. You can't just task kill Process Monitor. It won't flush out the file and make it succinct, and it won't work. So you have to cleanly stop Process Monitor traces. It takes a while because there's a lot of data, obviously. Yeah. A lot of this is actually the thread profiling I turned on. So this is remembered a lot of thread stacks, so a lot more data. Have you ever done this yourself?
I haven't done this. So typically, I mean, we talked about this on defrag. I'll use like Saludo to determine boot logging, but this is actually looking at the detailed data.
It is.
Where Saludo is just, a tool for,
everybody else,
mom and dad to figure out why their computers run slow.
This gets me every time. You guys cross, and I get this Office Space moment. No, not the second bar. And so this is all of the activity of the box. What we're going to do straight away is go into the process tree graph. And you can now see, I'm going to make this really big, you can see who made who, right? And you can see it from the start. So there's no orphans anymore because you always know who the parent is. And so it starts off with system. SMSS is the session manager. This is the person who gives you like the credentials to be a workstation.
Yeah.
And then you can see it going through lots and lots of programs. Lots and lots of programs. You can see the tree, and then down here you can see another system manager. So this one is the one where the one up here is the root of everybody. This is the one which NT services run under. So this is console 0, session 0. And then this is the session that I logged into. So in XP, they used to be the same thing. In Vista, it was split out because of security concerns, and now you have 2. So all your services are under there. Here's WinLogon, that's the control.del screen. So, and then it uses the program called Logon UI to bring up that little area. And then here's user init. So in this period here, that was it waiting for me to press control.del. User init is when I actually finally typed it, and then Explorer starts. So there's a little period in here where Explorer was the only program running in my user session.
Yeah.
So here's the, this is kind of going to get personal about what you do, what situation you have and what part you want to look at.
Yeah.
I'm going to look into this little area here because it's kind of interesting. What you do is you double click on this guy, and what that does is it will highlight the first occurrence of that, the process start. And so we are looking at a graph between process start of this guy and process start of the next guy. And so what we can do on this side is go exclude events before. So everything that's before this point, we don't care about.
Yeah.
And then we're going to double click on the next guy, and that goes to his process start, and we're going to go exclude events after. So now we have a window of what happened in that time. And we want to know why Explorer was slow, right? So now we need to start looking at some of the data. So let's look at the overall activity of the box. Well, there was a lot of, across the board, a lot of disk activity, right? Which immediately makes you think, well, maybe the disk is saturated, and that's what it is in this case. Here's Explorer. He was trying to do disk at the same time as everybody else, right? He did 2,800 files events, which is a fair few. And looking around the the other guys. Yeah. So you can pretty well go. Well, actually, there's 9,000 up here. So there's 2,500 odd for Explorer, but there's nearly 10,000 for MSMPEng. MSMPEng is Microsoft Security Essentials, and so this guy is virus scanning anything this guy does, and he's busy having to load all his signatures and stuff like that. Yeah. If you look at other things like Registry, yes, it was kind of busy on Registry as well, but the MSEng didn't have any Registry. So you can kind of say, well, it wasn't Registry contention, but Registry has to come from a file, right? So that's some of that usage. Network-wise, close to 0 is irrelevant. And then here's the amount of memory. So if memory was really, really high, you also would start going, well, maybe there was some paging involved because I had to go to the page file. So immediately you know that this thing is a file-based issue, right? So then we go, well, what kind of files are being loaded? So let's filter this down to just files, just to make our numbers less. And we know that MSN is doing other files. We can't care what Explorer is trying to open. See if there's something in Explorer we can get rid of that's not required. So we'll just go down to Explorer. As you said previously, it's all about the filtering. Yeah. You've got to get your data down. If you try to open a file that doesn't exist, it still causes an I/O. So in this case, we're not going to filter down to success because we want to know holistically, this is all our operation it took, this is how busy I was. So let's use another graph, the file summary graph, and look at this guy. So there's 2,800 events, which correlates to what we saw in the other page, and we're trying to read 10 megabytes. Well, how long is this? We're going, well, 10 meg, that's not too bad. Let's have a look. So we've got relative time. So what sorry, it's even not here. So relative time tells us from the start of the boot that this happens at 35 seconds into the boot, and the other side process starts happening at 40 seconds. So there's only a 5-second window in there. This graph...
Platter drive or SSD in this machine? Yeah.
I think it's only a 50, it might be a 7200, but yeah, it's not, definitely not SSD. So out of the 5 seconds we were running, there was 1.7 seconds of I/O. So we got about a third of the disk capacity, right? And remember back at the other graph, we saw that Defender, Security Essentials got 9,800 requests.
Yeah.
Put those two together, you go, well, I got about a third, and he asked about 2/3 about what, he had 2 or 3 times more than me. Odds are that between us, we just used up all of the disk I/O, right? So let's have a look at the files. If you want to drill down, what you can do is if you have a guess that, well, if a program runs and then is dormant for a while, and then all of a sudden it does a whole lot of other things, the odds are it's still loading. This is 10 megabytes. You can kind of guess there's only 10 megabytes of DLLs and exes in Process Explorer at this point. So let's go to another view and go to this one, and we'll turn our file off, and we'll just say load images. So this is all of the DLLs that are loaded, and all you have to do is a quick scan and go, you know what? I reckon there's about 10 megabytes of DLLs there.
Yeah.
Right? And this is the last one. So remember how we've got that time thing on at the moment? So let's get rid of that time one. And so date is it's less than this one. So this is that's the thing at the end bound coming in. Just disable that one for now, and scroll down. And I'm scrolling down. No more events. So you kind of answered your own question. Since there's no more events after that point, you can say, well, there was this much disk activity. Security Essentials was using a lot of the disk up, checking my I/O, and when the process started that Explorer launched, after that there was no more DLL loadings for Explorer. Well, he was busy. He was busy loading. He just hasn't got to that point. Kind of a good example, I think, of what you can do in the bad cases. What you're looking for accessing network paths.
Yeah.
What you can do is add the duration column and use that as a quick guide. Show me every operation that took more than 1 second.
Yeah.
Right. Just
or
take
sort
it
by duration, see what your longest process
Yeah, you can't do sort, unfortunately.
Ooh.
Yeah, there's no sorting in Press-More because but you could export to CSV.
Yeah, you could do
that way.
Bring it into Excel, pivot table, boom.
Boom. Well, don't forget, you've also got you've got the counts column, and it's not going to work too well with duration, but because it's down on, actually duration is not even available because it's not that appropriate.
Yeah.
So yeah, it's up to the user to use a bit of logical thinking about what's this program doing at this point in the boot process. The Windows internals book, not the System internals book, the Windows internals book has a chapter, like chapter 4 from memory, on boot. It tells you A runs, it has this purpose. B runs, it has this purpose. If you're not familiar with why things are in the tree that they are and why there could be a delay, go get the book. It's Windows Internals 6th edition, Part 1 is the edition that has this chapter. Once again, it's like $20-something at Amazon, and you can delve into it. It is one of those things where you do need to have some domain knowledge to understand what's going on, but everybody can tackle it and get an idea. And if you get one of these cases where you just don't get it, email defrag. We'll absolutely have a look at it for you, yeah.
Very cool.
So that's boot logging.
All right, and that's how to troubleshoot how a slow machine might be causing you problems and figure out how to make it faster. And that is the last of Process Monitor.
Yep.
Next week,
we're going to go on to, it's kind of like its cousin that we use, auto runs. So auto runs lists everybody who starts a boot. So a lot of the things we've shown in the boot logging, you go, well, that's the cause. I don't even want him to run. Instead of going hacking the registry to get rid of it, we'll use auto runs to find and diagnose those things. And we'll also use auto runs to work out whether we trust that program in the first place.
Yeah. All right, that's the show for this week. If you have any questions, then you can leave us a comment in the show notes and we'll get back to you. Or you can email us on defragtools@microsoft.com and we can do a little bit of back and forth to help work through some of the questions that you have. Yep. Thanks for watching.
Have a good week.